In question 2, we are given this situation. There's a light elastic spring with natural length L. It has a modulus elasticity of lambda and it's on a smooth plane, the plane from A to B. This plane is smooth. And we are given that tan theta would be 5 by 12. And there's a mass of there's a particle of mass m attached over here. Now we're given that the particle is released from rest from here, from B, and due to the elastic force, the tension, it moves up. As it moves up, the tension decreases while the mg sine theta remains the same. At one point, t will become less than mg sine theta and it will start to decelerate the particle B until it comes to rest. And we are given the information that when it comes to rest, here, that when it comes to rest, when it first comes to rest, and they have said instantaneous rest, so after it's at rest, it will start to fall back again. So at this point, AC would be 0.7 L. So if this point was over here, this would be 0.7 L and this would be 1.3 L. In question 1a, we have to use the principle of conservation of mechanical energy to find the value of lambda. So we'll use the work energy principle. Energy loss plus work done by external forces equals to energy gain plus work done against frictional forces. Here there are no energy, there's one energy loss, the EPE loss, the elastic potential energy loss. There are no external forces or external work done. When the particle moves up the ramp, it will gain GPE, so there's an energy gain, GP gain, and since the ramp is smooth, we don't have any work done against frictional forces. So EPE loss equals to GPE gain. So the initial elastic potential energy when the ball is at B is lambda L square by 2L. It's basically the modulus times the extension square divided by 2 times the natural length. And when it's at C, its final elastic potential energy is lambda into 0.3 L whole square by 2L. At this point, the spring was extended, but when it's 0.7 L, the spring is compressed. If this was a string, it would have no elastic potential energy when it was compressed, but as it is a spring, it will have elastic potential energy when it's compressed as well. So when it's compressed like this, its compression would be the natural length minus its actual length right now. So the compression would be 0.3 L. Now we can just write this down. The EP loss equals to EP1 minus EP2 equals to mg del h. Now we have to find the change in height. So let's go here. We are given the value of tan theta equals to 5 by 12. So we can draw a triangle like this to find the value of sine theta and cos theta. And we can draw this triangle over here to find the change in height, because we need to find this. So using Pythagorean's theorem, we can find this. This is a 5, 12, 13 triangle. So sine theta will be 5 by 13 and cos theta will be 12 by 13. Now we can write, we can see that sine theta is h by 1.3l. h by 1.3l. So h will be 1.3l sine theta. And we also have the value of sine theta over here, so we can just plug it in there. So this is h, and we know the value of sine theta to be 5 by 13. So we can just calculate pi l square by 2l minus lambda l square by 2l minus lambda into 0.3l whole square by 2l, which would be 0.455 lambda l. And on the right hand side, we'll have mg into 1.3l into 5 by 13, which would be 0.5 mgl. The l's cancel out over here, and on the next line we can show that lambda equals to 100 by 91 mg. Now in question B, we are told to find the acceleration of P when it is released from rest at B. So at the moment it was released, we need to find its acceleration. So in this case, we will consider the forces. The unbalanced force would be, in this direction you'll have tension, and in this direction you'll have mg sine theta, the component of weight parallel to the plane, parallel to the ramp here. So at B, the resultant force F will be T minus mg sine theta. Now tension in this case will be the modulus times the extension divided by the natural length. So we'll get MA equals to lambda times L divided by L minus mg into 5 by 13, the value of sine theta. So in the next line we can just write MA equals to, this is the modulus, this is lambda, we just place this. We can cancel the masses from here. We'll get acceleration equals to 5 by 7g, and that's the answer.